All right, let's look at the homework 10.6, problem number 5. All right, so it says this. A typical problem from a previous chapter is given, a Newton's method to approximate a solution. A company estimates that the cost of producing X units of a product is given by, here's a cost function, and find a production level that minimizes the average cost per unit, all right? So let's do that. So I'm going to use GeoGebra here. All right, so I'm going to actually copy this first. So I'm going to copy the function here. All right, and then here's the GeoGebra. All right, so I'm going to define a cost function. So cost function colon equal. So I'm going to paste here. All right, so we got the cost function. Actually, I have to didn't have to do the power correctly here. All right, so here. All right, here's the cost function. And then average cost, I'm going to call it the average cost of x and colon equal. All right, it's just a c of x divided by x. All right, so this is the average cost. All right, then we want to find we want to minimize this guy. All right, so let's see. Maybe I'm gonna just look at the picture here. All right, so I think the window is too small to see it. All right, so let's see if I can rescale this so that we can see the picture a bit. All right, let's see. All right, right here. All right, maybe I have to. All right, so you can see that here. All right, this is going to be the minimum value right there. So I'm gonna stretch it out. Yeah, now we can see it better. So you can see that the smallest point is somewhere around here. All right, so we're gonna use Newton's method to find that. All right, so what we're gonna do is let's see. So we want to minimize, so we have to take the derivative of this. So I'm gonna call f of x as the derivative of this function because we want to find a critical number, right? So we have AC prime of x, right? So this is going to be f of x, and we're going to try to find the 0 of this function, right? So we don't have to see that. All right, so we're looking for that. So here, all right, so Newton's method function, I'll just call it the n of x as usual, x minus f of x over f prime of x. All right, so we got that. So all right, then x1. We can x1 set to be since somewhere around here, so it's gonna be I would say it's like a 120-ish. So I'm gonna put 120. Right? Doesn't have to be 120. You can do 110 if you want. All right. So you have we want to find x2 would be just Newton's method, plug in x1 here. All right, and let's see, so x3 is equal to n of x2, and maybe x4 is equal to n of x3, and so on. All right, maybe I'll do one more. X5 is equal to n of x4. All right, so we have that. All right, so what precision do they want? Nearest, all right, around to the nearest integer. So I think we're already there. All right, so the nearest integer would be, you have 131 and 45, 46, so it's going to be 131. All right, so let's type it in. It's going to be 131. All right, check the answer. All right, it came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.